So I got a comment on one of my earlier videos from a user called Alex Crosby who was asking whether I could do a video on saving and loading the Capture the Sarrum game as part of the Section D kind of questions. So I'm going to go through that today. There's two main methods which we can use to save data. Well, two methods that I know of in VB.NET. So we can either save it as a text file, which obviously saves it as text, or we can save it as a binary file. Now these work in slightly different ways, you use them in slightly different ways, but they both have their own advantages. So a text file, as the name implies, simply prints text to the file. So we can create a text file like, say we were in Notepad, we would get a file that said like 56 on the next line, 75, or Jimmy, I don't know, something like that, and that would be how it would save. That's how we would save the data. And this is useful because we can use that data outside the program. We can access it just by opening the text file in Notepad or Word or whatever, and we can read the data ourselves as humans. The advantage of a binary file is, well, it just says it's binary, it's just raw data, which can be useful in some cases. Now with both of these file types, the method, or the concept behind the method that we use to write the file is the same. It's the same for reading. So say we have our program here. We have such and such a program doing something or other, and we want to save or read or write data to a file over here. In order to do that, we need to open a stream, or a file stream as it's called. So that would basically connect this program to this file and say, right, I'm communicating with this. And this is often what happens with files, so sometimes you might not be able to open a file or delete a file because it's in use by another program. That's because it has a file stream like this open. So if we have if we're writing a text file, this will be a .txt file, so .text obviously. And when we are writing data to this file, we will just simply send the text, and we'll say, right, we'll send Jimmy down the thing, and that'll travel along, and we can say write line. So we can use the same way as console. We can write a line to the text file, and that will simply write the data and then go on to the next line. And that can be useful. Is we can, when we're retrieving the data, we can then take this back and pass it in our program, so we can create a big array of all the data. The way a binary file works is we send values and their variable type. So we might say, I'm going to send the string Jimmy, and that'll go along, and it'll be saved as the binary of ASCII of Jimmy. It'll say, I'm a string, this is all my data, end. And the advantage of that is we get all the data saved in a certain order, and we know where the data is. Now, in the Capture the Sarrum program, we need to save two bits of data. We need to save the current layout of the board, so where all the different pieces are, and we need to save whose turn it is, which handily is called whose turn. With the board, this gets a bit more complicated because the board is a two-dimensional array, so we have this when we're declaring it. It's a two-dimensional array of size board dimension, so it's effectively 8 by 8. So when we're saving the board, what we want to do is we want to save every single part of the board into the file. Now, with a binary file, you simply can't do that. You can't save a two-dimensional array into the binary file. It won't accept that because it's a data structure. It's not actually a variable. It's lots of variables put together into one, and we can't save that directly to a file. So the way we will do it with both of these ways of saving is we will use a nested for loop. So I have two for loops, and then we will save each square of the data as a different variable. So in the text file, we'll write a line of each square, and with the binary thing, we'll simply write each square as a string, because remember there's two characters, so we can't use a character. And then after we've done that, we will save whose turn either as a write line or just as a character in the binary file. So now that we know roughly how it works, hopefully, let's move over to Visual Studio and we'll have a look at how to actually implement it. So if we're looking at what I have here, I've quickly set up just how to save and load the program. So I've added some extra bits into the code. So I said on this first question it says, do you want to play a Samco into your YFS or enter L to load game? And the way I've implemented that is when initialize board gets past sample game, I've also given it whose turn just for the sake of loading the game. So it gets past sample game, which is the input to this question, and if we go to initialize board, we'll see that I've added another condition here. Now it's got a bit of line under it because I've deleted the subroutine which I was using to make sure I knew how to do it. So it says if sample game equals Y, it'll set up the sample game, else if the sample game is L, it will load the game from the file. And then to save the current game, I simply have at the end of each turn, at the start of each turn, pardon me, just a little question, do you want to save your game? And then if the uppercase of the answer is Y, then it will save the game. And again, it's saving the board and whose turn. Now, let's go to the bottom of the program and we'll start having a look at how to implement these. So let's work on the save current game sub first. So we're going to go save current game. And we're going to need to pass this, the board and the whose turn, we need to pass it by value because we don't need to edit them at all. So we're going to say by value board as string, remember it's a two-dimensional array, and we want to pass it whose turn as a character. We could use different names for these, but I'm not going to for the sake of clarity. Okay, so within save current game we're going to create a Streamwriter object, and that's going to be a Streamwriter as system.io.streamwriter. Now I am putting system.io here. What I could do is I could go to the top and I could say just below imports system.math, say imports system.io, and that would mean that we don't have to use that. So this is a namespace. This is just a library of programs which we can access. So the system.math is for the absolute value of a number. System.io is for file streams and writing data and reading data from files. I'm not going to use that for the sake of drilling it into your minds that there needs to be a system.io everywhere. So I'm going to keep that there. It'll just be easier to remember, it'd be for clarity. So we now have the object, but it's got a green line under it because we're not actually using it yet. So what we want to say is we want to say that the Streamwriter equals new system.io.streamwriter, because this is irritating. So this is why it's better to put that import at the stop. It makes this much easier to type and to understand. It's less words, obviously. And this will take a couple of arguments. So we want to give it the path of the file where we're saving it to. So we need to give this as a string. And let's say savegame.txt. Now this actually saves to the file, if I can find it quickly. So when we're in the save stuff here, we can see we're in the Capture the Sarrum folder, and we can see this folder here called bin. I don't know if that's binary or bin, but hey, it's there. So any files that we write from this will automatically go into this folder here, the debug folder. So you can see I've been testing this, so I've got savegame and savegame.bin. So I was testing text and binary files. So actually I'm going to delete those just for compatibility. So they'll save into here. It's quite a tidy place to put it, and it's not in the way of anything. And Alex Crosby said something about changing everything on his desktop to Sarrum or something, so I'm quite worried about what happened there. But that's where this file will save to automatically. You can change the domain for this, but often you won't ever need to at this level. So I'm not going to go into that yet, half because I don't know how and half because I can't be bothered. So yeah, so we need to give it the file name, or the file path, and we also need to give it another parameter, which is whether to append the file or not. Now, if it was to append the file, it would add the new data that we're writing to the end of the current file, which is there. But we don't want to do that because we want to overwrite the data with the most recent saved game. Obviously, you could, as I said, have a user-defined save file, which would make life a bit easier. So I'm going to set this to false. I'm not going to append the file. I'm going to overwrite it every time I save the game. So now we've opened that file stream, we can start to write the data. Now, I mentioned before that we're going to use a couple of for loops, so I'm going to use a generic counter. So I'm going to say for I equals 1 to board dimension. So we're using the constants here as, well, it's good practice, and it's already there, and we know it's always going to be the right size for this array. I'm just putting step 1 for neatness sake, I don't know, I like it. And I'm going to use j for the inner loop, so I, j, and k, and whatever. It's just, they're good counter variables because they're local, they won't go anywhere else, and they're simple to just pop in there. And you don't have to declare them. You could if you want declare them at the top of the sub here, but I'm not going to because, well, I just don't want to because it's easier this way. So there we are. Now we have our structure for iterating through the board array. So I'm going to say Streamwriter. So remember, we're accessing a text file, so I'm going to say write line. So we're writing a line. It's going to put one bit of data and then go to the next line. Write line board I, j. So this is going to write every single element of the board array. We're not including the 0 rank and the 0 file because no one uses those. I'm going to write all of those to the file in order, in a very certain order. So remember, we're going through the i's and then the j's. So as long as we read it in the same order, we won't get any messed up boards. So, and then we're going to simply go Streamwriter dot write line whose turn. So we're just going to pop that on the end of the thing. We can load that after the board, and that's going to work. So when we save our game, it will open a file stream, and it will save the data, and it will then write the whose turn bit. There's one more thing we need to do with this sub. We need to put a little line at the end here that says Streamwriter dot close. So what this will do, this will close the file stream, and it will stop you having any errors of not being able to load the program or anything. It's very neat. It's very tidy programming. It's a bit naughty not to do that. So you need to make sure you put that close at the end. So we're closing the file stream, saying right, we're done with that file. It's left there. We're going to carry on with what we're doing and not focus on that. So this is our save game structure. So we open a file stream, we save the data, or write the data, and then we close the file stream. And it's a very similar technique for the load game sub, except with the load game we need to do by reference with the board and the whose turn, because remember we're assigning them values based on the data that we read from the file. So because we're assigning the values, we need to give them by reference so we can change them. And we're going to use the same technique. We're going to say dim stream reader this time though. So instead of writing, we're reading the file, and system.io, I put caps lock on by accident, stream reader. I'm going to do this fairly quickly because I want to get onto the binary files. I don't want this to be too long a video. And I'm going to have access the same file as the writer access, so it's doing that. And this doesn't, I don't think this needs any, no, we don't need to put any more arguments in this. We don't need to know whether it appends the file. So the file path is adequate when loading the file. So let's have a look at this. So we're going to have the same kind of iteration. So we're going to say for I equals 1 to board dimension, step 1, and we're going to say for j equals 1 to board dimension, step 1. And this time we're going to assign each spot in the board. So we're going to say board ij equals stream reader streamreader.readline. So this is very similar to how you use the console write line and read lines. It's the same kind of thing, except we're not getting the input from the user, we're getting it from the file that we're reading. And we're going to use the same technique for the whose turn. We're going to say whose turn equals, not console.readline, dear me, streamreader.readline. Oh, what's happening? And then we're going to close that stream as well. So streamreader.close. Now, you may be wondering, if we just keep on reading the same line, how does that work? So what this actually does is, when we read a line with the stream reader, it'll say, right, I'm going to read this line, and then it kind of skips itself down to the next line. It says, right, I'm ready to read this line now. And so the file will, every time you read a line, it will slowly iterate through the file. And because we know exactly how much data has been saved there, we're not going to have an end of stream exception, hopefully. So if I run this now, you can see that we get enter L to load game. I'm not going to do that yet. I'm going to press N. And I don't want to save it yet. I'm going to move a piece just to show that it works. So I'm going to go 2726. Just going to move the white red in there. Do you want to save your game? It's black's turn. That piece is moved. I'm going to say yes, I want to save my game. So that is saved now. It doesn't look like it, but it has. And so I'm going to start the game. I'm going to say L to load game, and there we are. It's loaded the game. I haven't changed all my desktop icons to Sarrum, and it's working. So, but it asks you to save the game. That's just the best way I could think about doing it. Now, a binary file works in a very, very similar way, except we have to access the file stream in a slightly different method. So the way we do this is, first of all, I'm just going to take all this code and delete it. I have it saved somewhere else, so it's fine. So when we're trying to create a binary file, what we need to do is we need to create a file stream object and then have the binary writer and the binary reader access that file stream. So it's a slightly different way of doing it. We don't have the same, the kind of all-in-one assignment to that file stream. We have a two-step thing. So we're going to say dim file stream as new system.io.filestream, and we're going to give that a similar pass, except this time we're going to call it savegame.bin. So it's a binary file, bin file. I think that's how it works. And this takes a slightly different second argument. So the second argument of the file stream thing is how you want to use that file. So if I put system.io.file mode, you can see it comes up with a few different options here of what I can do with it. And because we'll be creating a file, well, I'm going to put create. So it's going to, I didn't mean that, I meant that. So we're going to create a file and we're going to write to that file. So let's just go down to here. We'll say dim binary writer. So we can call, obviously we can call these whatever they want. Common practice is often FS for file stream and binary writer for BW for binary writer. So those are quite common things, but I'm just using full names just for ease and clarity again. So I'm going to call this, I'm going to assign this as a new system.io.binary writer. Now this takes an argument again. I'm going to say it is a binary writer which is accessing file stream, which is something we assign just above it. So we're saying I'm going to open this file stream. I'm going to have this binary writer access that file stream. And so now we have this binary writer which is open. It's ready to write the data. And so we're going to use the same loops again. And I might skip past me writing these. So now I have that same structure in place. So I have a nested for loop for writing the board and just one last one for the whose turn. So the only difference is that we're using a slightly different word here. We're saying binary writer.write, and we're not using write line. We're just using write, because it'll write them all in order as different variables. It'll say this is this variable, this is this variable, and we have to access the each element of the board, because we can't write just a whole two-dimensional array to the file. We have to write each individual element. So it's the same structure, and a disadvantage of this, I suppose, is that we have to close both the binary writer and the file stream separately. So we just stick those two lines on the end. And the load game, again, is almost exactly the same thing. In fact, so similar, I'm going to copy all of this down. So I've just added the same kind of structure to the load game subroutine. The only difference being the first bit, that I'm using system.io.filemode.open. So I'm not creating a file to load it, obviously. I'm going to open the file that we've already saved as savegame.bin. And again, you could use user input to have a custom file name, but not going to go into that yet. And instead of using something like streamreader.readline, I'm going to say board ij equals binary reader dot read string. So with a binary file, you have to specify what kind of variable you want to read. It's a bit awkward, but if you know what data is in that file, then this is a very useful way of accessing it. So we're going to read a string every time we go through each array, and because we know what order it's been saved in and exactly how much of it has been saved, again we get this very discrete set of values which we know we can iterate through a certain number of times, and it will read exactly the right ones. And I'm going to use the very same technique with the whose turn. I'm going to say whose turn equals binary reader dot read character, and that's going to be the same kind of idea. So let's start a new game. I'll do the same thing. I'll just move the same piece. Oops. I've messed up there, haven't I? Okay, let's restart this. I don't want to do this. I don't want to save the game. I want to go 2726, and I want to save the game here. The same position again, except this time it's saving it as a binary file. So I've saved that. Let's close and restart, and we can load the same game back, except this time it's loading the binary file. So that's basically all you need to know in terms of saving and loading files. It's not too complicated, but the binary stuff especially can get a bit over the head. I didn't really get that until yesterday when I taught myself. So I hope this helps, and if there are any other queries or items that you want explained, please do comment, and I will do my best to do a video on it and explain as best I can. Thank you for watching.